Okay, and we're back, and I wanted to talk about factoring the greatest common factor before we continue in the series. And so over here on the left, I've just got a set of two numbers, and then you see a bunch of polynomials on the right, and we're going to be factoring those as well. So taking a look at these two guys here, just numbers, 56 and 24, when I talk about the greatest common factor, first of all, I'm talking about common factors. If you recall, a factor of a number, or factors, that is, are numbers that are multiplied to give you a number. So suppose I'm looking for two things that are multiplied to give me 56. I could say 7 times 8. I could continue this, even breaking down the 8 and saying that that's 2 times 4, and then 4 is 2 times 2. And what I'm doing here is the prime factorization, just so that I can see all the numbers, all the prime numbers that are multiplied to give me 56. So I can confidently say that 56 is equal to 2 times 2 times 2 times 7. All of these prime numbers right here. And again, all I'm looking for is what are the numbers that are multiplied to give me 56 in its most basic form. Let me do the same thing to 24. Let's say that that's 3 times 8. That's just the first thing that comes to my mind. And then 8 is 2 times 4, and 4 is 2 times 2. So I can say that 24 is 2 times 2 times 2 times 3. And looking at this list, actually, you can see all the prime numbers that are factors of each number that are also common for each number. Notice here that these guys are common. We've got another pair of factors that are common. We've got another pair of factors that are common. So in fact, I can say that 2 times 2 times 2, which is 8, is common to both of these numbers. And in fact, it is the largest number that is common as factors of both of these numbers. So I'm going to call it the greatest common factor, GCF, and that's equal to 8. Again, it's the largest number that go into these two numbers. Well, when we're talking about polynomials and we're factoring polynomials, we're concerned with not only the largest number that goes into each term, but if there is a variable factor, we're considering factors, variable factors, that are factors of every term as well. So let me explain in more detail by example. For this first trinomial, 4x squared plus 8x plus 16, I notice that there is a common factor of 4 in all of these terms. We see a 4 there. 4 times 2 gives us 8. 4 times 4 gives us 16, so at least 4 is common to all of them. Some people get confused and say, oh, it's 16, the greatest common factor is 16, but hang on, 16 is not a factor of 4. 16 times what equals 4? So we don't look at it that way. We look at it as the largest number that goes into each one of these numbers evenly. So I can take out a 4 as the greatest common factor. Then I look at the variables and I ask myself, I see an x squared here. Is there at least an x in every other term? I don't see one, actually. I see an x here, but this one doesn't have any x's, so there is no greatest common factor among the variable parts of it. So far, simply the greatest common factor that I see in this polynomial, this trinomial, is just 4. And what I'm going to do is factor that out of each of these terms and put it off to the side, and then put a set of parentheses here. What I have left in the parentheses are every term divided by the greatest common factor. So 4x squared divided by 4 is x squared. 8x divided by 4 gives me a plus 2x. 16 divided by 4 gives me a plus 4, and then I'm going to put my other set of parentheses. And what I have shown here is equivalent to my original trinomial, and it's a factored form of the original trinomial because I have something times something else. And that's what factors are. They are just something times something else that gives you your polynomial in the first place. Now I should also ask myself whether or not x squared plus 2x plus 4 can be factored into something else, and we'll explore that in other videos. I can tell you that it cannot. So actually, this right here is my factored version of the trinomial above where I have factored out the greatest common factor. The greatest common factor is integral to any factoring process, and you should always take out the greatest common factor first. So let's take a look at this guy and ask ourselves again, what is the greatest common factor? Well, the numbers look the same. We've got a 4, 8, and a 16. So we know that 4 is the greatest common factor. But what about the variables? Well, it looks like there is at least 1 power of x in every one of these variable terms. I can't say that there's at least x cubed in this, right? Because there's only an x. But for x squared, which is x times x, I can say there is at least an x in there. I can make the same argument for x cubed. Therefore, the greatest common factor between these three terms is 4x. And I am going to continue to factor this by factoring out the greatest common factor. So I'm going to put it out here, put another set of parentheses, and divide each term of my original polynomial by that greatest common factor. That's what goes in here. So 4x cubed divided by 4x gives me an x squared. And you're going to have to remember your rules of exponents to be doing this. 8x squared divided by 4x is giving me a plus 2x. And 16x divided by 4x gives me a plus 4. You'll notice that in this case we ended up with the same trinomial as we had there, but we had that extra x that we had to factor out. And this is it. This is our factored expression of the original polynomial. Again, you should take a look at that trinomial. Maybe that factors into two binomials. Look ahead to the videos that follow this one to learn how to do that. Take a look at the next example, 5x to the 5th y cubed plus 10x to the 4th y to the 5th. This is a binomial, and I want to factor it if I can, so I'm asking myself, is there a greatest common factor? Certainly with the numbers, 5 here, 5 times 2 is 10, so 5 is a common factor, and in fact it's the greatest common factor. What about the variables? I have an x to the 5th and x to the 4th. X to the 4th is the maximum number of x's, if you will, that I can factor out. So x to the 4th is the greatest common factor, along with y cubed. There is at least a y cubed and y to the 5th. So without writing the greatest common factor explicitly this time, let me just go to the factored form. I'm going to take out the 5. I'm going to take out as many x's as I can, which is x to the 4th. I'm going to take out as many y's as I can, which is y to the 3rd. And put in parentheses my original binomial divided by my greatest common factor. So I took the 5 out. It's no longer here, or another way to say that is I get 1. This guy divided by this, as far as numbers is concerned, is 1. For the x's, I end up with just an x, and you can see that the y's would cancel out. So all I'm left with is x plus 10x to the 4th y to the 5th divided by my greatest common factor would give me a 2. X to the 4ths cancel. Y to the 5th divided by y cubed is y squared. And there it is, the factored form of my original expression. And again, what that means is that 5x to the 4th y cubed times this binomial, which means times each of these terms, gives me the original polynomial. And that's why we're dividing as well as a procedural note. Okay, so this is nice, pulling out a greatest common factor that is a monomial. 4 is a monomial, 4x is a monomial, 5x to the 4th y cubed is a monomial. But let's take a look at factoring out a greatest common factor that is a binomial factor. Notice up here in this example that we have a 1 minus y occurring in a couple places. Okay. And we can factor out that 1 minus y just like we were factoring out common monomials. So I'm going to state it explicitly, the greatest common factor, that it is a factor of both of these terms. It is a factor of both these terms. Is 1 minus y. It's a greatest common binomial factor. So what would I get if I divided both of these terms by 1 minus y? I would get, I'll use the pink here. First, my greatest common factor out front, just to stay consistent with what I've been doing over here. So there's my greatest common factor. What I'm left with goes in its other set of parentheses here, and that is 2x plus 3. We can see that if we divided this product, 2x times 1 minus y quantity, divided by 1 minus y, these two things would totally cancel, and all I'm left with is 2x. Same thing over here with the 3 times the quantity 1 minus y. Divide this piece by 1 minus y, and we get this. Now here's the weird thing. If you wanted to check this, you might be tempted to do 1 times 2x plus 1 times 3, and so on and so forth. What that would equal is if you took this original expression and multiplied it all out and combined the like terms. Another way to look at it is if you take the entire 1 minus y times 2x, that's this part. The entire 1 minus y times 3, that's this part. So you can say confidently that yes, indeed, this is equivalent to my original expression. And that's how you factor out a common binomial factor. Notice the next example. I tried to illustrate a common binomial factor that may not be obvious. Right here we have 8x times the quantity x minus 1 plus, let me do this, the quantity x minus 1. Okay. Now you may not see those parentheses at first. It may be up to you to insert them. And I'm actually going to insert one more piece here in addition to that. I'm going to put a 1 in front of that quantity. So now it looks a little bit more clear. Okay, yeah, there is a common binomial factor. It's right here and here. X minus 1 is being multiplied by 1 here. X minus 1 is being multiplied by 8x here. So without explicitly stating the greatest common factor, let us factor out the common binomial factor of x minus 1. Then what I'm left with in the other parentheses is 8x plus 1. And I get that by dividing this by x minus 1 and dividing this by x minus 1. 8x plus 1 is what remains. All right. Factoring out the common binomial factor is an integral step to factoring trinomials by grouping. AC method, AC, and then to grouping. Again, I'll talk more about that on a future video. Take a look at this bottom example. Here's another one that might trip you up. You might say there's not a common factor or a common binomial factor. But this one is a little sneaky. If I'm looking for a greatest common binomial factor, then what I'm looking for is something that looks exactly like this binomial being multiplied by 8x. I'm looking for an x minus 1. This one, negative x plus 1, kind of looks like x minus 1, but the signs are incorrect, right? Or let me just say that more explicitly, the signs are opposite. So this one is tricky, but you can factor out a negative 1 from these two terms here, and look what we get. This would give me 8x. I still have my times x minus 1 here. I'm going to factor out a negative 1 just from those two terms on the end. That gives me a positive x minus 1 as what remains. Aha, now notice I have the common binomial factor of x minus 1. So I'm going to factor out my x minus 1. And what I'm left with in the other set of parentheses are these two terms divided by x minus 1, which gives me 8x minus 1. Here's the minus 1 right there. Okay, so that one was a little bit trickier. But still, I could say there was indeed a greatest common factor, and that greatest common factor was the binomial factor of x minus 1. So have fun with this. The greatest common factor is very important for the rest of the factoring business. So give it a try with several other examples on your own. Let me know if you'd like to see another example from me.